Well, howdy there, Internet students. It's Mr. Hermanson again. This is Objective 7.2 A and B extra practice if you want to retake the test. I'm going to do the first problem from each set and give you some helpful hints. You're going to finish that practice, and then you're going to send me a picture of your work or a PDF preferably. Anyway. So this first problem, we just want to find the solutions, and we do that by the balancing method. So I'll draw my line here. I need this x all by itself, so I'm going to add 2 to get rid of that negative 2. And that gives me 22 is greater than x. Now remember, 22 is greater than x is the same as x is less than 22. And then, so on my number line here, I'll just put 20, 22, 24. We need less than 22, so we're going to put an open circle and have it go that way. All right, one little reminder, make sure you're listening to this. On the next problem, the inequality symbol is going to reverse because you need to divide by negative. When you need to multiply or divide by a negative, you have to reverse the sign. All right, let's move on here. Do number 2. Now these we have x's on both sides of the inequality, so we need to get rid of the x's from one side first. So always get rid of whichever one is smallest. So since 2x is smallest, let's get rid of that first. That gives us 4x minus 15. We're going to keep it greater than because subtracting does not change the inequality symbol, only if you multiply or divide by a negative. And 5, I'm going to add 15 to both sides. I'm running out of room here, so I'm going to put my answer, my next step over here. So I get rid of the minus 15, so now I have 4x equals, well, it's greater than 20, dividing by 4, and we get x is greater than 5. So we'll put 4 here, 6, 8, 5, and then your arrow should go that way. All right, go ahead and finish those up. Moving on to the next one. More solving inequalities. I'm going to pick one here where we have to do more than one thing. But it looks like on all these, we're going to have to get rid of the parentheses first. So I'm going to do this one right here. So multiplying this out, I get negative 3x plus 21 greater than or equal to 21 minus 3x. I'm going to get rid of the 3x on this side, so I'm going to add 3x. And something weird's happening here. I end up with 21 is greater than or equal to 21, which is true. But since that's always going to happen no matter what x is, any number will work here. So all real numbers are solutions to this one. Now, if this would have been false, then we would have said there's no solution. So on some of these, there may be an unusual situation there. Okay, number 4, write and solve an inequality here. So an elevator has a maximum weight capacity of 2,000 pounds. That means that when you load the elevator, it has to be less than or equal to 2,000. So right away, there's your inequality. There are already 4 people on the elevator who have a combined weight of 620 pounds. So we're going to put 620 over here. And so we can add some weight. We'll use W. but it always has to be less than or equal to 2,000 pounds. And then all you have to do is subtract the 620 from the maximum total, and you end up with 2,000 minus 620 is 1380. So the rest of the weight you put on there has to be less than or equal to 1,380 pounds. So that's how you would do that. All right. Now we're up to objective 7.2b. It says circle all numbers in a row that are solution. Now, to be a solution, remember that this absolute value is going to turn the number positive. So if it's already positive, it's going to be the same. So in here, we're just checking, is 6 less than 7? That's true. Let's circle that one. Now this -6, when we put the absolute value on it, I should have done that here, but we know that's 6. Anyway, the absolute value of -6 is actually 6. So this is just like saying 6 is less than 7, which is true. 6 is less than 7. How about -7? The absolute value of -7 is 7. Is 7 less than 7? No. And the last one, the absolute value of 7 is 7. Is 7 less than 7? No. So check each of those solutions, circle them if they're true. All right, number 2. Absolute value inequalities have 2 parts that are true. They have a negative part and a positive part. You need to get both of them. So to get the negative part, you're going to write 2x, flip the sign, and then you're going to make it a -5. Or, now if it's greater than like this, then it's going to be an or situation. If it's less than like the one down here, then it's going to be an and situation. And the other one is just exactly the same as it's written, just without the absolute value. Okay, so we're going to divide both sides by 2. We get x is less than -2.5. Or dividing this one by 2, we get positive 2.5. That one's greater than. So let's put a 0 here. Let's make the scale a half. So I'll put a 1 here, 2 here, 3 here. That'll make it easier to graph. So we have less than -2.5. That's right there. Less than goes that way. We have greater than 2.5. That's right there. And that one goes that way. So if it's greater than, you're going to end up with 2 separate parts of the graph going in opposite directions. If it's less than, like on this one, you're going to have the graph where it comes in between. All right. Number 3, what are the solutions to these inequalities? On this first couple, we have some junk outside the absolute value. You want to get rid of that first before you find the negative parts and the positive parts of the solutions. So start by getting rid of 10 from both sides. Then you end up with the absolute value of x is greater than or equal to 6. Now you can make your 2 equations, your -1 and your +1. Your -1, flip the sign, make it -6. Or the other one is, we're just going to leave it exactly the same way it is, just get rid of the absolute value. So we get x is less than or equal to -6, or x is greater than or equal to 6. So I'm going to go by 2's here just to make it easier to fit. Those are negatives. So less than or equal to -6 will be right here. Solid circle this time. Put the arrow. Greater than or equal to 6 will be right there, going that way. All right, one more problem. The important part on this is that you write the inequality. Okay, we're going to use a absolute value to help us show something here. It says the ideal circumference of a regulation softball is 12 inches. When they make those, they never come out exactly 12, but they will accept a little bit of variance up to 0.25 inches. So in other words, the difference between the circumference of the ball they create and the ideal circumference can't be more than 0.25. So if I make a softball and I find its circumference, let's call that C, and if I subtract the ideal circumference, that can't be any more than 0.25. So that means it's less than or equal to 0.25. Now the problem with this is, what if the circumference is less than 12? Then when I subtract over here, it's going to actually be a negative number. So I'm going to use the absolute value to get rid of that negative. So I just want the positive difference, basically, is what I'm saying. Now, when you solve this, you're going to have C minus 12. These are the negative solutions. And so you switch the sign and make it 0.25. And then over here, I'll do the positive solutions, which is, we're leaving exactly the way it is. Now over here, you're going to add 12 to both sides. Whoops, I forgot to make that a negative. Sorry about that. When you do the negative solutions, you flip the sign and make it the negative. And when I solve this one, I get 11.75. And when I solve this one, I get 12.25. All right, so finish those up. And when you got it done, you're going to send me a picture of your work. I'll check it. If it looks good, I'll send you a new test. Talk to you later.